So from the previous course, we know that only about electron, proton, neutron. So we only know about these three particles, and we consider these three as the fundamental in the previous course. But now in AS, we are going to add some other particles. For example, if we talk about proton, neutron, electron, etc. So we will discuss that these particles are also made up of some other particles also. So we have other micro nanoparticles available also that are going to make up these electron, proton, neutron, etc. So that is the concept of particle physics. And previously, in nuclear physics, basically, in nuclear physics, we studied about isotope, gold foil experiment, and nuclear fission, nuclear fusion reaction. So we only study about these three elements especially. But now we are going to add some more in this chapter. So first of all, we need to make a standard concept of the models, like what type of elements we are going to discuss and what are their specific categories. Because category is very important to remember, because this chapter is especially based upon the knowledge of the groupings of the elements related to the standard model. So for example, if we consider standard model first, because we already know about electron, proton, neutron, so that's why we are not starting from there. We are starting from the standard model. And in standard model, there are general two categories. So on one side, there are fermions, and on the other hand, we have bosons. Now let's see electron, proton, neutron, these three elements. So which element is going to be categorized in which one? So after fermions, fermions further categorize into two more classes, that is hadrons, and the other classification of fermions is leptons. Because sequence and classification is very important in this chapter, because in questions also they used to ask about the categories, the classifications related to the particles. Second category is leptons. No, basically, we are going to classifying from the basic to the advanced one, because we are using electron, proton, neutron. We know about these names. But if we further go in the basics of these particles, so there are some other micro nanoparticles available that are making up the whole structure of proton, neutron, electron. Okay, basically, we are talking about more fundamental particles. Before AS, we only studied about that three particles, and we considered those three particles as fundamental. But now we know about basics. So we are going to study about the further detail, that what are the fundamental and the basic elements that are making up these electron, proton, and neutron. Okay. So hadrons, leptons, these are not electrons, these are not protons, these are not neutrons. These are like different categories. For example, if we talk about hadrons, so in this chapter, we will study about quarks. So these hadrons are actually made up of quarks. We will discuss what are quarks, what are their classifications. So all informations are included. But right now we are just making a standard model, like how many elements are there and how many categories we need to remember in this chapter. So that's why we are just making a journal model. So basically in hadrons, hadrons are made up of quarks. And if we talk about leptons, so leptons are itself fundamental particle, because leptons are not derived from any other particle. So leptons are fundamental. And in the category of hadrons, because it is mentioned, it is made up of quarks. So definitely we have other categories also in hadrons. So yes, we have two more categories in hadrons. One category called baryons, and the other category is mesons. So basically, hadrons are also made up of some other fundamental particles. So these are the other particles, baryons or mesons. So there are two process or two different process that makes up hadrons. In the category of the baryon, what is the difference between baryon and mesons? So general difference is, since hadrons are made up of quarks, so it depends upon the quantity of the quarks. Like in baryons, we are going to use three quarks. So when we are using three quark system, it means that element is called baryon. And when we are only using two quarks, so that is the category of mesons. We will discuss further in detail that what are quarks and how to find out the values of the quarks. But right now, only journal representations. And in the category of baryons, now we are going to write the name of the element that we use normally in our syllabus, in our chapters. So the first name is proton. So basically in proton, proton is made up of three quarks actually, and it is in the category of hadrons. Secondly, neutron. So neutron is also in the same category of baryons. And these are general representation, like proton is positive charge, we know neutron is neutral. And there are some anti-particles also. Electron is not anti-particle of proton. Electron is opposite to proton, right? Values are same, but their charges are different, right? But if we talk about proton, so exactly the anti of proton is equals to anti-proton. For example, if we used to write +1 and if we write -1, okay? So these two digits are exactly anti of each other. When they combine, so they cancel out each other. So that is called anti-particle. When they combine, so they cancel out each other completely. So two particles are antiproton, antineutron. So now it is very easy to remember proton, neutron are in the category of baryons, three quark system. And we have two particles more that are actually anti-particles of proton and neutron. Antiproton, antineutron. Simple. Because electron is not the anti-particle of proton, because the category of electron is different, and only in electron magnitude is same but charge is different. So that is not like proton, that is in the other category. And for example, in our syllabus, we will study this sequence of baryons in detail, but mesons are not very in very much detail, just like the baryons, because we know about proton, neutron. These are the previous concepts and the topics that we already studied. So that's why we will discuss this baryon category in very detail. But in mesons category, we have one element pi positive and the second one is pi. So these particles are actually made up of two quarks. And after this, if we move on to the next category, leptons, because leptons are itself fundamental. And if we write down the name of these fundamental elements, so in the fundamental elements, first of all, we have electron. Second, mu is the second particle. Third element is tau, and then neutrino. So these four elements are in the category of leptons. So these elements are actually, these particles are fundamental. These particles are not derived from any other. These elements are itself fundamental. And the other category, that is bosons. So right now we mention about fermions. Now if we talk about bosons, so bosons are basically force carriers, because in the category of fermions we actually discussed about charge carriers like positive, negative, neutral, etc. But if we talk about bosons, so we are talking about with the reference of forces. So general concept is bosons is the study of like force carriers of the particles, and in fermions we are actually working with the charge particles and the concept of the charge carriers. And for bosons we have category like gluon, W boson, Z boson, photon, graviton, and Higgs boson. So these are the elements in the category of bosons. So first of all, our main focus is on fermions, because in fermions we know many elements in the category, but in bosons we don't know about any one of it, because we never discussed about these force carriers before. So let's suppose if we start with the fermions category. So first of all, starting with the category of hadrons, because in hadrons we have a concept of quark, and there are three quarks, two quarks, and they are making up proton, neutron, antiproton. So let's see how they are making up proton, neutron, etc. And before that, one more important thing. If we talk about four fundamental forces, in mechanics, generally we discuss about so many types of forces. But if we talk about fundamental forces, so there are four. All other forces are actually drive forces. So these four forces are the basic or fundamental in whole universe. The first one is strong nuclear force. Like this strong nuclear force is naturally already available. We are not making this force. We are not like exerting this force in any reference. And the second one is electromagnetic. So electromagnetic is also fundamental. Number three, weak nuclear force. And the fourth one is gravitational. So these category of the forces are the general and fundamental categories of the forces of the universe. And basically, if we talk about this strong nuclear force, so this strong nuclear force is actually experienced by the quarks. So with the help of quarks, we are getting proton and neutron. So that's why in the nucleus we have a strong nuclear force. It is written a strong nuclear force because in nucleus we have protons and neutrons. So that's why this force can be experienced by the quarks. And if we talk about weak nuclear force, so weak nuclear force is due to quarks plus leptons. So when there is a combination of quarks and leptons, so we will get weak nuclear force. So when there is only combination of hadrons or the quarks, so there will be strong nuclear force. But when there is a combination of quarks and leptons, we will get weak force. And now let's start with quark. Any question in this journal concept of the elements standard model and the standard forces, fundamental forces? Okay. Okay, next category is about quarks. So in the category of the quarks, basically, these are the elements that are made up of six different categories, or we used to write six different flavors of the quarks. So let's see what are their categories and how they are going to make up proton and neutron. So basically, quarks are fundamental particle as we already observe in the table. So these are fundamental particles, and just like we observe, they are making up to proton and neutron category, also in the antiproton and anti-neutron category. So this is the simple concept of quarks. And if we talk about their categories, so there are total six different flavors or six different types of quarks that we use. The first one is called a quark, and the second one is the opposite of up is down. And in the same way, we have charm. Then we have strange. Top and bottom. So basically, these are the fundamental particles in the quark category, and the difference between them is very simple to differentiate them. First of all, the upper category like up, charm, top. So these names are like on the top, and down, strange, bottom. These are the opposite of the names mentioned on the top side. So basically, the value for up or the charge for the up we used is equals to plus 2 over 3. In the same way, the value of charm is also same. So the charges for up, charm, and top, these quarks remain same, plus 2 over 3. And if we talk about down, so the value or the charge of the down is minus 1 over 3 E. And for strange, E. And if we talk about bottom, E. So basically, these actually quarks never exist in like individual forms. So we always find particles where there we found like a combination of the quarks. For example, if we consider the category of the proton, so in the category of the proton, there are three quark system because it is mentioned in the category of the baryons. We have to combine three quarks. So when we combine three quarks, so naturally in proton, two quarks are up, up, and one down. So now you can take the values from the quarks already mentioned. So the value of up is plus 2 over 3, plus another 2 over 3e. And finally, because of down, it will be minus 1 over 3e. So it will be equals to 2 plus 2, 4, 4 minus 1 equals to 3. So finally, we got result plus 3 over 3e, which is actually equals to. So that's why we always used to write the charge of proton as positive 1, because it is made up of quark, and from this category of the quark we are getting answer positive 1. So that's why the charge of proton is also 1, because it is made up of the categories of the quark up, up, down, and it always remains the same for proton. We are not going to change because we have same values for charm and top. But definitely, these are natural elements and the particles, and when scientists and they actually perform experiments and they observe the particle, so definitely the properties they observe, so the same property we are writing down. And in the same case, if we consider neutron, so the category of neutron is also in bosons. So for neutron, it is up, down, down. So now in this category, for up quark, the value is plus 2 over 3e minus 1 over 3e minus 1 over 3e. So after combining up, you will get answer 0. It means no charge on neutron. So this is the explanation of protons and neutrons, that how we are getting this positive and zero charge or neutral charge on the protons and neutrons. In the same way, if we consider the antiparticles, because we also mentioned antiproton and antineutron in the category of baryons with three quark system. So basically, in antiparticles, or we also call them antimatters, so antiparticles or antimatters have same mass but opposite charge. So they have same mass but opposite charge. Okay, so in the concept of antimatter, we were talking about that in antimatter we have same mass of the particle or the element but opposite charge. And in the second point, when matter collides with its corresponding antimatter, just like we previous discussed the example of +1 and -1. So +1, -1 both are opposite to each other, and when they combine, so definitely final result will be equals to 0. So in the same way, when matter collides with its corresponding antimatter, they annihilate each other, and in this process, basically this process is not necessary in this chapter right now. We will discuss this concept in A2 in next year. So right now it is not important. But in this process, what happens actually, energy is released in the form of electromagnetic radiation. So when they combine with each other, energy is released as electromagnetic radiation. So this is the concept of antimatter. And just like we discussed about the quarks in proton and in neutron, so in proton we have up, up, down. So basically in antiproton, if we consider antiproton, it is equals to anti-up, another anti-up, and anti-down, right? Just like in the concept of the proton, we used to write U, and the charge of U is +2/3. But we used to write for antiproton U with bar over it. So bar represents anti-up. So anti-up actually gives you the value of negative. So it will be equals to the negative value 2/3e, 2/3e. And this anti-down will be opposite to the original down value, that is -1/3. It becomes +1/3 because charges are opposite but values are same. That is the concept of antimatter. So final answer we will get equals to -1e. So basically this element is exactly like a proton but only different in charge. Okay. And in the same way, if we consider anti-neutron, so in neutron we have up, down, down. So in anti-neutron, it will be anti-up, anti-down, and anti-down. Then the concept of anti-neutron, just like we mentioned, anti-up, anti-down, anti-down. So final result will be equals to 0, but representation will be different. So it will be equals to -2/3e plus 1 over 3e plus 1 over 3e. So when we combine them, again it will be equals to 0. So now combinations are completely opposite to the original one, but results are same for neutron because neutron is definitely equals to 0. So it remains 0. And definitely we will also discuss about the category of fermions because electron is in the category of leptons. So right now we only discussed about the three quark system. In three quark system, we consider proton and neutron, and we also discussed that how to combine quarks to make up neutrons and protons, right? So any question, any confusion from this? Okay. So basically, it is mostly like a learning based chapter as compared to the other chapters. We need to remember some names and some charges. And after this, before starting the electron category, we need to discuss the radioactivity concept because in radioactivity, in beta decay especially, in beta decay, we actually discuss about beta positive and beta negative decay because in beta positive beta negative we will get that charges also different types of charges, so we will also discuss that radioactivity concept again in this chapter, but with advanced concepts in beta positive and beta negative decay. Alpha remains same. And further we have category of leptons also. So next category is leptons. Yes. So basically, we actually revised the same idea, the equations of decay, but now we are going to discuss in further detail, like what is the concept of just like beta positive, beta negative, and what are the other fundamental particles we will get. Because right now we know about fundamental particles. In previous syllabus, in previous course, we don't know about these fundamental particle names. We are only working with proton, electron, neutron. So those equations are very basics. But right now we know about fundamental particles. So we are also going to add those fundamental concepts. So next category of fermions is leptons. And leptons are also fundamental particles, just like quarks, fundamental particles. And in the same way, we have six category of leptons. There are six leptons altogether. Okay, the first one we have electron. Next we have muon. And the third one is tau. And the opposite categories are electron neutrino, electron, neutrino, then Muon neutrino, and third one is tau neutrino. So, just like in proton, neutron, we discuss antiproton, antineutron, and in the category of the quarks, we have top, charm, and up, and the three other names are the opposite of top, charm, and up. In the same way, we use electron, muon, tau, and the other are the opposite of electron, muon, and tau. So names are easy to remember. So basically, these all elements, especially if we talk about muon and tau, because we already know about electron. Electron is like element that we already studied about. But especially if we talk about muon and the tau category, so these are very similar to electron. So both categories actually. So these are very similar to electron, but with slightly greater mass. So the mass of muon and tau is greater than electron, but exactly they are similar to, almost equals to. They are look like exactly to electron. And definitely they also have negative charge just like electron, because electron also have negative charge. And if we talk about these special categories, this is the category related to. And especially if we talk about neutrinos, so basically neutrinos are like most abundant elements because they have no charge and almost negligible mass. So especially for neutrino, so neutrinos are most abundant leptons in the universe. And why they are most abundant? Reason is very simple, because they have no charge and negligible mass, almost equals to 0, right? So that's why these are most abundant elements or the leptons in the universe. So in the categories of the forces, just like we mentioned, strong nuclear force, electromagnetic force, weak nuclear gravitational. So in leptons category, they interact with weak interaction, electromagnetic, and gravitational. But just like we mentioned in the category of the quarks, so a strong nuclear force is only for the quarks. But if we consider leptons, so in leptons, they do not interact with strong forces, right? Only quarks can interact with strong forces, and this is the difference between the category of leptons and the quarks. Okay. And further, we already discussed about baryons and mesons, that there are three quark system, and in mesons we have two quark system. And after this, in this whole chapter of the particle, we now next time we have to start with the concept of radioactivity again, because that radioactivity is a complete topic. So we start with the radioactivity idea, and after radioactivity, we know about the decay particles like alpha, beta, gamma. But in beta decay especially, we have two concepts like beta positive and beta negative decay. So we need to differentiate between them also, that what is the difference between beta positive and negative, and what elements we are getting in beta positive and beta negative decay. And rest of the chapter consists of the categories of the particles that we discuss, fundamental one. So other than that, in this chapter, you will not get any specific type of other questions or calculation that is required especially. We will discuss about the concept of electron volt, because normally we use energy in joules, but we can also use energy in electron volts. So the conversion of that electron volt from joule is also very simple. So inshallah, next time we will start from the radioactivity idea, and we will complete this chapter, and after that we can practice questions from this specific chapter. Okay.